Okay, so today we have lesson 17. This is beginning to wrap up our unit on quadratic functions. This one here is going to be graphing using standard form, so the form that we've been using for the quadratic equation and all those things, or the quadratic formula, I'm sorry. So it's just kind of wrapping it up and using everything that we've known to this point. This opening exercise is just kind of a conceptual understanding of what these graphs are saying, what is going on. So we're going to work through this. So it says a high school baseball player throws the ball straight into the air for his math class. The math class was able to determine that the relationship between the height of the ball and time, since it was thrown, could be modeled by this function. So here's our function right here. It's a quadratic function. So t is going to represent time in seconds since the ball is thrown, and h represents the height of the ball in feet. So that's going to be above the ground. So in letter A, it says, what does the domain of the function represent in this context? So what it's going to represent, it is the time the ball is in the air. So when we're looking at this, a couple of things to remember. So the first thing is it's going to start at 0. If we were to find an x-intercept that was before 0, we don't worry about it. It starts at 0. So it's going to be the time the ball's in the air, or you could also say the time since the ball was thrown. That would be another good way to answer that. So what does the range of this function represent? So the range is going to be what it's set equal to, our output. So our output is going to be the height of the ball. So it's the height So it's going to be the height of the ball. And I also say above the ground. So, of course, the ground will stop it from falling. So the next one, C, at what height does the ball get thrown? So if we remember, the height's going to be thrown is our y-intercept. So our y-intercept we find by making our x, or in this case our t, 0. So negative 16 times 0 is 0. 96 times 0 is 0, and then we have 6. So what would be the height the ball is thrown? 6 feet is the initial height. Again, that would just be plugging in h of t, or h of 0, equals negative 16 times 0 squared plus 96 times 0 plus 6. And so that's going to equal 6. So 6 feet is the initial height. Okay, after how many seconds does the ball hit the ground? So when we work with this one, we can actually use completing the square to help us figure this one out. So the first step is rewriting it back out. Negative 16t squared plus 96t plus 6. This is when we want to get it to equal 0. So our height would then be at 0, so we'd hit the ground. So now we can solve by completing the square. So we're going to subtract 6 from each side. So we have negative 16t squared plus 96t, put a little lip on those so they are a little more obvious, equals negative 6. So to complete the square, we need to divide negative 16 out of each of these. So then we get negative 16, and you get t squared plus, it would be 6. And since we pull out the negative, this now becomes a negative as well. Negative 6t, and then that's going to equal negative 6. Okay, so completing the square, if we take half of 6, we're going to get negative 3. Negative 3 squared will be 9, so we need to add 9 in here. So we have t squared minus 6t plus 9, negative 16 outside equals, and so that's going to equal negative 6, but then we also need to add the amount that we added to this side to the other side. So 9 times negative 16 is going to be negative 144. So that's how much we would have added to this side. So we would have added a negative 144. So then we also have to do it to the other side. So then that's going to give us negative 16 t squared, I'm sorry about that. Okay, so it's going to give us a negative 16. We'll leave that on the outside. Then we'll have t minus 3. That would be this factored out. That's going to equal negative 150. So then the next step is to divide by negative 16. When we divide by negative 16, we're going to get t minus 3 squared equals negative 150 over 16. And we can actually get rid of the negatives. They'll cancel each other out. So next step, square root each side. So when we square root each side, now we're going to get, work here in the center, t minus 3 equals square root of 150, and it'll be over 4. We know what the square root of 16 is, so that will be fine. So then to end it, oh, do not forget it's plus or minus. We'll have to add 3 to each side. So t equals plus or minus square root of 150 over 4 plus 3. Okay, and then that'll give us, one of the answers would be t point equals 6.06. So that would be the seconds where it hits the ground. So we can use completing the square. If you also wanted to, you could use the quadratic formula to work through this and figure out what are our two answers. The negative 1 we're going to discard because we can't have a negative time, and then we take our positive answer. So we can figure this out. You can either do it by completing the square or the quadratic formula. Either one is fine. So for E, this is where the quadratic or completing the square is kind of handy. So it says, what is the maximum height of the ball reach while in the air? How long will it take to reach its maximum height? So if we think back to before, last lesson we talked about vertex form, and that's the completed square form. So when we look here, we can actually make this one right here, make it all equal to 0 and have it together, and we'll have vertex form. So that'd be negative 16 t minus 3 squared, and that's going to equal, oh, sorry, we'd add that 150 to each side, so plus 150 equals 0. So now we have our vertex form. So if we look here, remember this number, if it's negative, we just take the number there. That's going to be our x coordinate, or t in this case. And then on the outside here, not in front, but on the outside and the back, you're going to get this 150. So that is our vertex. So it says, what is the maximum height? Our y is our height, so it'll be at 150 feet. And how long will it take to reach its maximum height? It'll take 3 seconds to reach that. So this is using vertex form. If you wanted to go through and figure out the x-intercepts and then find the middle of them and all that, you could, but at the same time, this will work, and it's fairly quick. All right, so almost done with this one. F, what features of this quadratic function are visible since it is present in standard form? So when we're thinking about this, we're thinking, what can I just look at this equation and figure out immediately? So the first thing that we can tell, and really the only thing, is going to be the y-intercept. If I make all of these x is 0, then I know what my y-intercept is, because that's the plus whatever on the end. So that's really the only thing that is very present at the beginning. You could also, I guess, tell by the leading coefficient if it's going to open up or down, but you can also see this in the vertex form as well. So what features are visible when rewritten in vertex form? This will be the vertex. The vertex is going to be present if you remember that h is going to be your x value and k is your y value. So it tells us our vertex, and the coefficients in the front can also tell us the end behavior, just like it can up here. So that's just something to keep in mind. If it's negative, then it's going to open down, so it's going to come down. If this is a positive, it's going to open up, so you're going to have positive end behaviors. So here is kind of just a list of things for general strategy when graphing. So you're going to want to start this. You're going to want to have this so you can easily get to it when you're graphing these. So the first step, so look for hints in the function's equation. So look for things you can immediately find. When we talked up here, we said that for this one, the y-intercept is obvious. You can also tell your end behaviors. For this one, we said you can see the vertex, and then you can also determine end behaviors with the A. So look for different hints that they're going to provide. The next one is solve. The next one is going to be solve f of x equals 0 to find x-intercepts. So we want to make our whole equation equal 0 so we can find the x-intercepts. You can do this by completing the square, you can use by factoring, or you can use quadratic formula. So you can use all three methods to work on that. So it may not be bad to also write that down just so that you are aware of that. So then the next one is going to be find the vertex by completing the square. Or using symmetry. No. So you can use this by when we did the factored form and we found the x-intercepts, use that then to find our x value for our vertex, and then we found the y value. So you can do that. Another way you can do that is you can do negative b over 2a. So you would take your b, just like what we did with the quadratic formula. You take b, plug it in there, and you'd find a, plug it in there, and you'll have your line. That would be your x coordinate. So this would be your x coordinate. So when you're finding vertex, you can always use this as a quick way to find your x coordinate and then plug it in and find your y coordinate. Okay, last one. Plot the points you know. And you need at least 3 points. It also wouldn't hurt to have the vertex. The vertex is really key, and I'd almost always try to have the vertex, and then you can either find the y-intercept and use it to find the extra point, and you have enough to graph, or you can have the x-intercepts as well. You need 3 points. The one that I would say you always need, though, is the vertex. So always need the vertex. Okay, this next one here, this example, we actually pretty much just did this in our opening exercise. It's applying these rules now to this example. I'm going to skip it because, like I said, we effectively did this just before this. So we're going to skip on past that, and we're going to move on to just these graphing ones. So I'm going to graph one of them, and then I actually want you to try and graph two, and at least get the graph for A done on your own, just so that you can get some practice graphing those. So identify the key features. Remember, these are going to be your x-intercept, your y-intercept, your vertex, and any extra points. So I would be okay with you finding your vertex and finding 2 other points as extra points. You need to have 2 of these 3 there for every single one. So just something to keep in mind. Okay, so we're going to graph this function and identify the key features. So the very first thing that I'd look to see is, well, first, can we tell anything just looking at this? This is in standard form, so immediately we can find the y-intercept. So if we plug in 0 for x's, our 5 is going to be our y-intercept. So y-intercept, that's going to be 0, 5. So we immediately have our y-intercept. So then the next thing would be, can I factor this? So if we were to look at this, my factors for 5 are going to be 5 times 1, negative 5 times negative 1. So one of them added together will give me the negative 6. That's going to be negative 5 and negative 1. Since there's a coefficient of 1 in the front, we don't have to do the AC method at all. So if we were to factor it out, we get f of x, or I guess this one is n of x, equals, and it'll be x minus 5, x minus 1. So if we set this equal to 0, then we're going to look at this and say what would make these 0. So for this one here, if we plug in a 5, we'll get a 0. So x equals 5, or in this case it'd be 1. So x will equal 5 or x will equal 1. So we have our x-intercepts. Our x-intercepts are going to be 5, 0, and 1, 0. So for this one too, I wouldn't complete the square to find the vertex. We can use our symmetry to find the vertex for this one. So if we were to add these two x values together, 5 plus 1, and divided by 2, we're going to get 6 over 2. That's going to equal 3. So that's going to be our x coordinate. If we plug in 3 into the original, we get 9. So 3 squared would be 9. Minus 6 times 3, so minus 18, and plus 5. So when we look at that, 14, you get negative 4. So that would be our coordinate point. So I found the x value by taking the average of these 2 points, and then I plugged it in for the x value, and we could figure it out from there. So then all you have to do is graph them. So our y-intercept is at 0, 5, 1, 2, 3, 4, 5. Our x-intercepts are at 1, 0, and at 5, 0. 1, 2, 3, 4, 5. And then our vertex is at 3, negative 4. 1, 2, 3, 4. Okay, and that's all we need. And then we'll just graph that, make some kind of a curve, and ta-da. So that would be the graph version of that one. Went by 1, so I didn't need to scale it. So I want you to practice on 2, and then I also want you to practice on 3a. So give those a shot, and then come back and we'll graph them. Okay, so for number 2 here, I just ended up graphing it out for you. So when we look at this one here, it's going to say, or the first thing we can tell is the y-intercept. It's in standard form, so we just need to plug in zeros for the x's, and we'll find that 6 is left over. So for this one, it's going to actually be pretty easy to complete the square. So we'll use completing the square to find the vertex and use vertex form. So for this one here, you pull out a half in the front, and your 6 needs to be kicked to the back. So when you pull out a half from both of these, you're going to get x squared, and it's going to be plus 10x. So you're dividing by a half. Make sure that you do that. So if you plug into your calculator, do 5 divided by 0.5. So then to complete the square, we're going to take half of 10, which is going to be 5, square that, and that'll be our number here. So we're going to add 25 out here. Now, when we do that, we subtract the same amount that we added. So we do 25 times a half. It's going to be 12.5, and subtract it from the outside. So now we have a half out front, x plus 5, that's squared, and then we have minus 6.5. So this x.5, or x plus 5, this is from this right here being factored down. So this is what it would factor into, and we just combine these two together and get negative 6.5. So when we're using vertex form, we take this here. If it's a positive, we have to make it the negative version, so negative 5, and then this number outside is just our y value, so negative 6.5. So for this one, I didn't even want to mess around with x-intercepts. You could. All you have to do is set this equal to 0, and then add 6.5, divide each side by a half, and then square root and all that fun stuff. So you could do that, but for this one, I'd actually rather just do the extra points, and then you can graph it based off the symmetry of that. So for this one, the y-intercept is 5 away, if we're talking about x distance from the vertex, so we'll go over 5, and then we just go over another 5. That'd be our extra point. So at negative 10, 6 would be our extra point, and those would be the 3 points that I would graph on there. They'd be the simplest and the quickest way to graph that one. Okay, for 3 here, so we're going to look at 3. On A, you should have graphed this. So again, I did the same kind of thing. Immediately, you can tell the y-intercept, so I used that to figure out the y-intercept. So it was going to be 0, and it's negative 100 if you plug in 0 for those x's. Then the next one was completing the square. It's an easy one to complete the square on. It's not going to be any nasty fractions or weird numbers. So I completed the square. For this one, I had to pull out a negative. So I got x squared, and then you have a negative 40x. So half of negative 40 is going to be negative 20. When you split it up into those two, then you're going to get x minus 20, x minus 20. Negative 20 times negative 20 is going to be this positive 400. So that's the value I add on the inside. So I need to subtract this from the outside. But I have to do 400 times this negative value. So negative 1 times 400 will give me a negative 400. I need to do the opposite, that's the outside. So negative 400 would have been added on this side. I need to add 400 to offset that one. So it'll be negative 100 plus 400. So this factored down will give us x minus 20 squared, and then we'll add 300. So our vertex is then just going to be taking this number right here, it's already a negative, and we just write the 20 down. And then the value on the outside is going to end up being our y value. So again, for this one, I would choose to do the extra point. The x-intercepts are important. They would be a good indicator for this one. Again, you could solve for those the same way, but we could get a general idea of where they're going to be using this here. So if you had 0 to 20, and you go 20 more, and you'll be back at the same y value. So 0 to 20 is 20, 20 plus 20 is going to be 40. So 40, negative 100. So if we're graphing this here, when we're at 0, we're at negative 100. I went up by 50s on the y-axis, and I'm going by 4s on the x-axis. So when we're at 20, we're up at 300. And then we'll go 24, 28, 32, 36, 40. At 40, we're back down at negative 100. So we can get a general curve here that we can see. It'll hit and start coming down. Okay, so the next part here, it says, according to the function, what is her initial cost? And so explain that. So when we're looking at this, before she has mowed anything, her initial cost is going to be this y-intercept. So she hasn't mowed any lawns. So her initial amount she has to put into it actually wouldn't be negative 100. She just have to put $100 into the company. So she's putting this in to help her get jump started and get it going. So this $100 is spent. It looks like negative 100 because she was spending 100. And this is just looking at profit. So if you're negative, you're spending money, you're not making the profit. So when we're looking at these ones here on C, to determine what two prices does she have to charge to make a profit, or between these two prices. So these are going to be all your values that are going to be above 0. So we're going to look at our x-intercepts here. So our x-intercepts, I just wrote them out. You could have found them by subtracting 300 to the other side if this is equal to 0, multiply it by negative. Yeah, you could have done all that stuff and figured it out. I just wrote it out over here just so we had it to work on these ones. So when we're looking at these two, between what two prices, so she needs to be between this price and this price here. So between 20 plus the square root of 300, which if you round it to our money values, it's going to be $37.32, and 20 minus the square root of 300. That's going to equal $2.68. So between these two prices. So this is going to be something that we could look at this and say, okay, this is where we would need to be to actually make money doing this. So the next part, D, if she wants to make a $275 profit this summer, is this the right business choice? So for this one here, we're going to look at the vertex. How much money could she make? What is the maximum amount? So the maximum here would be 300, and that's going to be bigger than 275. So yes, because her max value is $300 that she could make. Profit here, her values here, her x's, are going to be how much she's charging per yard. So if she wanted to make the most profit, then she's going to charge $20 per yard. She'll make the most profit, and then she will make that one worthwhile. So on 4 here, I'm just going to kind of talk about it real quick. This one is another projectile motion. So we have a negative number in front, meaning that it's going to open down. So it's going to go up and then come back down. And again, just like with this one here, you can kind of tell right off the bat where this would be our initial height, this would be our starting costs. So we can kind of see those things from the beginning. Again, this one's all very similar to our very first one that we did. So I'm not going to beat the dead horse with this one, and we're just going to keep moving. So on 5, notice how the profit and height functions both have negative leading coefficients. Explain why this is. So for this one here, explaining why it is, with a height for projectiles, they're going to go up, then down. And they will have a maximum. So they're going to go up and down. That's how projectiles work. You know, the old saying, what goes up must come down. So it's going to go up and then come back down. And so you're going to have a maximum. The only way you can get that is to have a negative number in the front. So for the profit one, this one is going to be a little bit different. Normally when we price things or when you're working with money, you want to find a sweet spot where you're making the most money for the item, but you're not charging too little. So there's normally an in-between spot that's going to be perfect for that. So for this one here, explain why this is for the profit. The total profit will increase as you charge more until people won't pay it. Then total profit decreases. So when we're looking at this one here, the total profit is going to increase until people have had enough of it, or it costs too much, and then it's going to decrease. You can kind of think of Girl Scout cookies. Everyone loves them, but if they were to charge too much for them, no matter how much people love them, they're probably going to buy them this much. Some crazy people would. That would be like your $37 up here, but some people also wouldn't, or more people wouldn't. So even though you're charging more, you're just breaking even. The same as when you can get a really small profit for each one, so you charge $2 each. A lot of people buy them, but you're not going to make any money because you're already negative 100. So there'll be a sweet spot right here, your maximum, where your product is charging a proper amount and it's going to make money from it. So that is why you would also have a negative curve with those ones as well. So that's it for lesson 17. Again, it's just kind of bringing the concepts together that we've worked with using completing the square, your y-intercept, and your x-intercept.